Okay, so in part one of the adversarial attacks on robotics pipeline, we discussed uh, P2P perturbation and then pixel to pixel scattered perturbation, and similarly, uh, average scared mask perturbation, dominant direction perturbation for surf. Indeed, we were about to discuss this perturbation when the video got ended. So we will start it from here. Okay, so here instead of they're using the same block, let's say 3 cross 3 kernel or 5 cross 5 kernel. Instead of changing each and every pixel of the like each and every pixel inside the kernel, they went with a strategy in which they changed one pixel and then they left one pixel as it is. This thing is called scattered perturbation. You're not doing the noise thing with every pixel. In fact, you're doing this with each pixel like one after the other. The pixels that are in gray are being added with the noise. And the procedure of adding the noise is like when, for example, you want to add noise here, you will take 3 cross 3 a kernel around it and you will replace this value with average of these 9 values. Similarly with this one, and by doing this, obviously you will not be like degrading the quality of the image, because you are now not changing every pixel inside it. The quality of the image will now not be reduced, or the image will now look as if something has done on it. Then another strategy is block to block perturbation. In block to block perturbation, they again use another bit more adversarial approach, or like adversarial pro max approach, yeah, to which they are calling greedy approach again. They created a 3 cross 3 patch around each feature, and now they divided it into 4 overlapping blocks. For example, this was the feature responsible, and they created 3 cross 3 kernel, and then they divided it into 4 overlapping blocks. First one this P1, P2, P4 and P5. Second block this one P2, 3, like they are saying overlapping. This pixel 5 is repeating in every block, and obviously 4 is 2 repeating, 6 will be repeating as well. Now they, and secondly, the decision to perturb the pixel is taken at block level. Sum of all 4 pixels in each block is evaluated. Now they will they will calculate the sum of each pixel, each block. For example, the sum was found 20 here, 30 here, 50 here and 70 here. And then the greatest value will not be perturbed. In the box, no, I think I'm missing something. The block with the highest sum is considered as reference block, and that will not be perturbed. Okay. Sum of pixel in each block is compared with reference block, and only those blocks are perturbed those difference is greater than a threshold. And in this case, let's say we were assuming this one got 70 value and this one 30, and now you will find the difference between the like blocks, and you found 20 here, like 10 here and 30 here. Now you will set a threshold that, let's say I assume that okay, I am keeping threshold as 10. Now after I will add noise to only that block in which the difference is greater to the threshold that I have decided. Let's say here it was 20 and 30. Now I will add noise in this block and this block, and now As you're seeing, the pixels are repeating in both the blocks. So it is quite possible that since blocks are overlapping, one pixel may undergo perturbation more than once, as you're seeing here. So here noise is added, and again in P2 is repeating here. After adding the noise here, the same like procedure will be done here to add the noise, and this P2 will change again. And how they are changing the pixel or how they are adding the noise? By doing this thing. Okay, they are calculating average of these three attached pixels to this pixel, and they are replacing the value here with the average of these three values, and they are doing this with every block. So this thing is called block to block perturbation. And now obviously in the paper you can find these tables with obviously good quality. The point to notice here, the like point to discuss here is that almost every feature was uh, like deceived except surf. See, Harris, fast, brisk, MSER. Every feature was like removed after addition of adversarial noise except surf. Surf showed resistance to their adversarial noises. Now to deceive surf, they did this. Scale specific perturbation for surf. Now for every type of noise that they created, ASM, P2P, PPS perturbation linked, they linked the kernel that they are choosing, 3 cross 3 or 5 cross 3 or 7 cross 3, the kernel they are choosing, to scale of the key point. As you know, they are in surf, features are detected in different scales, on different scales. So they decided a strategy. Okay, let's take 5 cross 5 kernel when feature is extracted at scale lesser than 5. Similarly, choose keyframe with scale. If the scale is between 5 and 10, choose kernel 7 cross 7, and then like apply the same things that you did here, but they just change the kernel size with respect to the scale on which the feature or the surface detected, and they managed to deceive the surf as well. So this was very good paper. There's many work, like there's a lot of work going on adversarial noises and how you can make your system good enough to not be deceived from adversarial noises. This was all about adversarial noises in robotics pipeline. See you in the next video.